everyone. In this video, we're going to discuss the topic about devices that are used to measure pressure, such as capacitive pressure sensor and strain gauge pressure sensor, wherein we're going to know the working principle and application of it. What is a strain gauge pressure sensor? A strain gauge, sometimes referred to as a strain gauge, is a sensor whose resistance varies with applied force. It covers force, pressure, tension, weight, and etc. into a change in electrical resistance which can then be measured. The working principle of strain gauge is that a strain gauge is a resistor used to measure strain on an object. When an external force is applied on an object due to which there is a deformation occurs in the shape of the object. This deformation in the shape is both comprehensive or tensile is called strain and is measured by the strain gauge. Application of strain gauge. Strain gauge are used to measure the torque applied by a motor, turbine, or engine to fans, generators, wheels, or propellers. This equipment is found in the power plants, ships, refineries, automobiles, and industry at large. Power is obtained by measuring the strain and rotational speed on a shaft. In addition, it is very important to know the methods of the strain gauge regarding measurement of its strength, weights, or force that are being applied to an object or structure, and also for us to be able to know the capacity or limit of it. What is a capacitive pressure sensor? Capacitive pressure sensors measure pressure by detecting changes in electrical capacitance caused by the movement of a diaphragm. How capacitive pressure sensor works? The capacitive pressure sensor operates on the principle that if the sensing diaphragm between two capacitor plates is deformed by a differential pressure, an imbalance of capacitance will occur between itself and the two plates. A capacitor consists of two parallel conducting plates separated by a small gap. Changing any of the variables will cause a corresponding change in the capacitance. The easiest one to control is the spacing. This can be done by making one or both of the plates a diagram that is deflected by the changes in pressure. Typically, one electrode is pressure sensitive diaphragm and the other is fixed. An example of the capacitive pressure sensor is shown at the right. An easy way of measuring the change in capacitance is to make it part of a tuned circuit, typically consisting of the capacitive sensor plus an inductor. This can either change the frequency of an oscillator or the AC coupling of a resonant circuit.